I just had the most incredible soup dumpling of this weekend. Anyway, day 36A, a lot of review. So, we've got perimeter, area, and our similar shapes. If you need help on this one, use the quick notes on the back. I've kind of highlighted the area and the perimeter and how they work. Important takeaway is scale factor squared for dilated area. And dilated perimeter is just straight up multiplication. So we'll do this one, and then you can try out the exit ticket if you'd like. All right, so we're going to determine our scale factor by taking the image of 12 and dividing it by the corresponding side in the original of 4. And we can see our scale factor is 3. So we're going to hand off our perimeter through the dilation of 3. So it's going to be the original perimeter times our scale factor, which will give us the dilated perimeter. So 26, 3, 78. Okay, area grows differently. We're going to write our original area, and we're going to write our scale factor. But we need to remember that it's the original area times the scale factor squared. So it's going to look like 36 times 9, or 3 times 3. And when we multiply that out, 36 and our scale factor squared, we're going to get 324. If you had 108, you forgot to square your scale factor. So 324 is our answer. You can try out the exit ticket if you'd like, or you can wait until the end of the class. I would suggest waiting until the end of the class. The back is the cheat sheet, and then the other handout that you have is just a bunch of practice, and it's starting off pretty easy, and then it's gonna, step up. So I'll do a couple of these, and you'll kind of fill in the blanks. So in 2, we have a proportion. That's a fraction equal to a fraction, so we're allowed to cross multiply. We're going to get 6x. The trick to this one is recognizing that it's 4 times that quantity. It's 4 times everything inside those parentheses that you're allowed to put there. And when you see it like this, it's obvious you have to distribute. So now you have 6x equals 4 times x and 4 times 5, which is 20. And now we have a nice algebraic equation we can solve. Get rid of the x's. And we're going to carry up our work. 2x equals 20. Divide both sides by 2. X equals 10. So use those parentheses so you can see the distribution. All right, we'll do 5 and 6 in here. And in these problems, the shapes are similar. They give you that. So if they're similar, that means a dilation took place, and you are allowed to create a proportion. Or you're allowed to work under the assumption that there's a scale factor that links these shapes. So I'm a fan of the proportion method. I'm going to take 3 and divide it by the corresponding side of 18. And I guess the key to this is just be careful when you set up your proportion. Make sure you're matching up corresponding sides, like the small side to the small side, and then this larger side of 8 to this larger side of unknown. Cross multiply, 3x equals, I don't know, 144? I have no idea. 8 times 18, yeah, 144. And then divide by 3. So 48. 144 divided 3. 48. All right, now I picked 6 because you have options here, and the fact that you have options might bother you a little bit. The one thing you don't have an option in is you're solving for the unknown. So we'll start there. We'll do this side divided by the corresponding side. And if I start in this shape, like this is on top, then the other shape needs to be on the bottom. And I could do 35 over 21, or you could have done the 15 over 9. Either one will work. Because remember, 35 and 21 are growing at some rate, and so is 15 and 9. They're going to grow at the same rate. That's why it's fine to use either. So we'll get 21x, 15, 35, probably 225, 15, 35. Yeah, oh wow, it's totally off. 525. And then divide by 21. Sure, that's a 25, yeah. All right, x equals 25. All right, in these sets of problems, 7 through 10, you are going to show that the shapes are similar or not similar. So you actually need to say similar or not similar and then have work to support that. Number 8 is a trap. There's just no other way about it. Still try them all. We'll do 9 and 8. In 9, you have options again. You just have to be consistent. So I'm going to do this base. I'm going to do this long base that's going to match this corresponding longer base. I'm going to put this one on top and this on the bottom of my fraction. So I'll have 16 over the corresponding 8, and that needs to equal, I'm going to do the legs, this 3.7 and this 7.4. So I'm looking at my notes, it's saying the 7.4 needs to go on top, and the 3.7 needs to go on the bottom. And I'm not going to do a proportion. I know I set it up that way, but I'll use equal ratios. I think that's kind of an easier way to see this. Let's see. So 16 over 8 is clearly 2. 7.4 divide 3.7. Not so clearly 2, but 2 nonetheless. And then the last one we have to do is that final base 2, the like top of the trapezoid, because that needs to grow at the same rate also, and we'll have 10 over 5, and that is clearly 2. And this is why I like using equal ratios, because in a proportion you're only going to get these two. Maybe those third pair of sides there don't grow at 2. Maybe they grew at something else. So the ratios kind of force you to do everything. So I've got my work shown, and I can say similar. And for today, we'll just leave it at that. Now, number 8 is the trap problem, because if you just use ratios, if you limit your understanding to this problem to equal ratios, then you're going to get an answer that just isn't correct. You'll have 24 over 8. That's going to give you something. And then you're going to have 15 over 5. And when you look at it this way, you can see that the scale factor is 3. And you'd be led to believe, like, oh, the sides are growing in proportion. They have the same ratio. So therefore the shapes are similar, right? That's what we would think. But if you remember the definition of similar, it is same shape and a proportional size. And the shape is controlled by angles. And that's what makes this problem unfair. If you look at this angle here, that's 65, in a parallelogram, consecutive angles have to be supplementary. They have to add up to 180. So if I take 180 and I take away that 65, I'm going to be left with 115. And then when I compare that to the other shape, 115 is not the same as their given 125. So because 115 doesn't equal 125, that means they're not the same shape. And if they don't have that same shape property, then they can't be similar. And this is why I said this is like a trap. The sides mislead you in here. And we haven't really talked about this too much. That'll be the unit coming next. All right, now the back is kind of where it amps up. I encourage you to try them all on your own, and then we'll kind of go over how to do them. So in 11, there's a strategy here. they're telling you the shapes are similar. They're similar triangles. And what makes this tricky is they give you a bunch of proportions. They're saying which one is correct, which one is a valid proportion to solve for x. And it's hard to work with things that people give you. And that's kind of the trick to solving this is, for number one, answer choice one, look at the first ratio, right? And then bring it back to the picture and see how they're making that proportion. They're doing like this base divided by 24. So if that's how they're doing it, x over the 24, then you would expect the right answer to mirror that. You would expect to see 15 over 9. And that's the trick. It's you look at the first one and then you make the next ratio based on what they did. And then you're going to match it. Does what you wrote match their answer? Here, no. They've swapped it. They have 9 over 15, so this is clearly wrong. I go back to the drawing board. I look at number 2. Now in number 2, they're doing 24 over the corresponding 9. So I would expect either 32 over 12, but they want x, so that's clearly not going to show up, or x over 15. And here, they've reversed it again. That's why number 2 is incorrect. Answer choice 3, they've got 32 over that x, so then I would expect 12 over that 15. And that is what I see. I do see 12 over 15. And that's why answer choice 3 is correct. And if you were to continue this logic with the fourth answer choice, 32 over the corresponding 12, it should be x over 15, and that's just not what they have. They have it backwards again, and that's why that's incorrect. So now that you kind of see how to do this problem, I'm going to push you to do a Common Core problem on the side. You can copy this down or just try it. But you want the one that's not correct. It's kind of the opposite of what we had just done. But we're going to resume, go back to our practice. And in 12, they tell you the triangles are similar. And my little hint to you is think about what creates similar triangles. Well, it must be a dilation. There must be some scale factor. When I think of it that way, I can't think of something easily that multiplies to 5 from 3. I can't think of something easily that multiplies to 6 from 5. And same thing with 7. So I'm not going to look at those answers yet. They could be right. I'm going to focus in on 4. Like, what could I multiply 5 by to get 10? Well, 2. So I would expect everything else to get double. This should be a dilation of a scale factor 2. So 2 times 12 is that 24, and 2 times 13 is that 26, and this is why answer choice 4 works. All right, and 13, there's like 2 parts to it. It's, do you know the properties of a square? Can you use this side length, right? RS is a side. You could draw out a square and name it, right? RSTV. Ask yourself, what do you know about all the sides of a square? It should be equal. And perimeter is simply add all the sides. So we're going to get 36 for that perimeter. And if you look at your cheat sheet, because now they're saying, a scale factor 3 happens, what's going to be the new perimeter? We go back to our cheat sheet. Dilated perimeter is just original perimeter times the scale factor. It's straight up multiplication. In the next problem, we're going to do the scale factor squared. But here, it's just that 36 times 3. That'll be 108. All right, now in the next one, they give us 2 things. They give us an area of 6 and a perimeter of 12. And it's still a scale factor of 3. So I'm going to focus on the perimeter of 12 and the scale factor of 3. I know the dilated perimeter should be 36. So I see 15, that's clearly wrong. 36 and 36, those are potential answers. 108 is clearly wrong. And now when I come to the area, right, my original area times my scale factor squared. That's going to be 6 times 9. 6 times 9 is 54. That's why area 54 is correct. If you just multiply it by 3, that's why you're going to think answer choice 2. All right, 15. It's similar. They have a new tenth, so it means it's the same shape. They say the equal sides, like this 10 and this 10, right? These sides, they're going to be 16. And we want to know what's the base, what's the value of the floor. So we're going to do 16 over the corresponding, 16 over 10, and then that's going to be x over 15. Cross multiply. Let's turn it on. 16 times 15. We'll get 240, and then when we do the 10 times x, we're going to get 10x, so we're going to have to divide by 10, so 24. So we're going to get 10x, we're going to get 240, divide by 10, divide 10, x is 24. Boom. And then in the last one, they tell us the triangles are similar, and they give us a bunch of stuff. The trick to this is matching up Q with L. Right? These are the same. Matching up R with M, and then matching up N with S. Okay, and you can kind of just visualize it. You can see that this side opposite that red angle is going to match that 7. And then they want ML. They want this side, the one opposite the green angle. So we need to use that 30. We're going to do 21 and 7. And then we got to do 30 and RX. And we'll get 21x, 7 times 30. $210, and then divide by 21. So 210, divide 21, divide 21. X is 10, right? 10 times 21 will give us 210. So at this point, I think we've kind of solved all the hard ones. And you can try out the exit ticket and kind of show that to me, and then hand that in on your way out. I hope this was a useful video, and I'll see you next time.